Hey, hi, this is Sabita Sundara. And today's question: how do you identify and resolve SQL deadlocks? This is one of the most common production support question asked for 8 plus years experience SQL developers, ETL developers, data engineers, and DBS. So let's understand it with a real time example. The scenario is like suppose two transactions are running at the same time. Transaction 1 updates account 101 and transaction 2 updates account 102. So initially everything looks normal, but suddenly one transaction fails with the following error. That is, transaction the process ID 57 was deadlocked on resources with another process and has been chosen as the deadlock victim. So the interview question may be, why did this happen? Or how do you identify the deadlocks? Or how do you resolve it? Then let's understand what it is happening internally. How deadlocks happen. So assume session A logs account 101. At the same time, session B logs account 102. Now, session A wants account 102, but session B is already holding that lock. Similarly, session B wants account 101, but session A is already holding the lock. Now, both sessions are waiting for each other. Neither session can continue. This creates a circular wait. This situation is called a deadlock. So, what a SQL Server does? Fortunately, SQL Server continuously monitors for deadlocks. So, when it detects a circular dependency, it automatically chooses one transaction as the deadlock victim. Usually, SQL Server selects the transaction that has the lowest rollback cost. So, that transaction is rolled back automatically. The user receives the deadlock error. The other transaction is allowed to continue and commit successfully. So remember, SQL Server does not solve both transactions. It rolls back only one transaction to break the deadlock. So how to resolve deadlocks? Now, let's discuss to prevent deadlocks. So I am giving solutions. The one is, every transaction accesses tables in the same order. Circular waits are much less likely. For example, instead of one session accessing table A, then table B, and another session accessing table B, then table A, make both access table A first, then table B. This is one of the best way to prevent deadlocks. Then solution 2 is, keep transactions short. That is, don't keep transactions open longer than necessary. Finish your work quickly and commit as early as possible. So, the shorter the transaction, the shorter the locks are held. Then, the third one is, create proper indexes. Also, poor indexing can force SQL Server to scan more rows, increasing log duration. So proper indexes reduce locking time and improve performance. Then the fourth one is, avoid user interaction inside transactions. Never ask for user input while a transaction is open. For example, don't display a confirmation dialog after starting a transaction. This is unnecessarily keeps locks active. Now, the fifth one is, use appropriate isolation levels. When suitable for your application, use isolations level like read commit snapshot isolation, that is called RCSI, to reduce blocking. Then always choose the isolation level carefully based on business requirements. Then the last one, the sixth one is, retry the failed transaction. So deadlocks can still happen occasionally. So applications should catch error 1205, that is 1205, and retry the transaction automatically. So this is a common best practice in production systems. Then the real time tips, interview answer. Now let's see how to identify deadlocks. If deadlock occurs, first check the error 1205 message. Then collect the deadlock graph from extended events. Then use DMVs to identify blocking sessions. If available, tools like SP who is active, that is a query, can help you analyze current blocking. So review the execution plan and transaction order. Then if the interview asks how do you identify and resolve SQL deadlocks? A deadlock occurs when two or more transactions hold locks on different resources and wait for each other, creating a circular dependency. So SQL Server detects the deadlock automatically and chooses one transaction as the deadlock victim. To troubleshoot, I check the deadlock graph, extended events, and DMVs. So, to prevent future deadlocks, I ensure a consistent table access order, keep transactions short. So, create proper indexes, use appropriate isolation levels, and implement retry logic for 1205 error. This answer demonstrates both conceptual knowledge and real production experience. In the real-time example, you can imagine a bank application. One transaction transfers money from account A to account B. At the same time, another transaction transfers money from account B to account A. If each transaction locks one account and waits for the other, a deadlock occurs. So SQL Server resolves it by roll back one transaction and allowing the other to finish. Then, as usual, interview tip is whenever you hear the word deadlock, remember these keywords. Then the first one is circular wait, locking, deadlock victim, error 1205, deadlock graph, extended events and DMVs, and retry logic. Mention these terms shows practical production support experience. Then deadlocks are a normal part of multi-user database systems. The goal is not to eliminate them completely but to identify them quickly, minimize their occurrence through the good design, and handle them gracefully in applications. So thanks for watching. Subscribe for more advanced SQL interview questions and real world SQL Server concepts. Thank you.